Imagine waking up one morning, and Earth is no longer the only home for humanity. What if we left our planet behind? What if the next chapter of our story begins on another world? Have you ever wondered what it would feel like to live on Mars? Or walk under the low gravity of the moon? Or maybe, just maybe, travel to a world outside our solar system? Today on For Science Salah Lotfy channel, we're opening the door to one of the biggest questions of our time. Can humans actually live on other planets? And in this episode, we're diving straight into three big ideas. First, why Mars, the moon, and other rocky worlds are even considered candidates for human settlement. Second, the real challenges. The harsh atmosphere, extreme temperatures, deadly radiation, and everything that stands in our way. And third, what science has achieved so far. Where do we stand in 2025? And are we truly getting closer to making life beyond Earth possible? So buckle up, because the journey starts right now. Credits, written and presented by Salah Lotfy.
Welcome to For Science Salah Lotfy channel, where global scientific research becomes clear and accessible.
هنا نحول الأبحاث العلمية العالمية إلى معرفة مبسطة مترجمة لك بلغتك.
Ici, la science est expliquée et traduite pour tous.
Ciencia clara, accesible y disponible en varios idiomas.
Wissenschaft, verständlich und mehrsprachig für jeden.
قناة For Science Salah Lotfy channel. العلم للجميع وبجميع اللغات. تابعنا لاكتشاف المزيد.
Why Mars? Why the Moon? These worlds are our stepping stones beyond Earth. Let's explore why they dominate our space exploration plans. Mars and the Moon are not just science fiction, they are practical targets. They represent what is possible and necessary for human achievement. We'll uncover why these celestial bodies are our most realistic options. Let's begin. The universe is vast, but distance is our first filter for space travel. Space travel battles distance, time, and resources. The Moon, just 384,400 kilometers away, is a manageable journey. Mars, at 55 million kilometers, is within reach with current technology. Venus is a toxic inferno, and gas giants are too far. The Moon and Mars are our most accessible targets. They are not just interesting. They are the only doors open to us now. Distance dictates our options. Mars is our most familiar neighbor, often called Earth's sibling. It has a solid surface and a day-night cycle similar to Earth's. Mars offers a natural circadian rhythm and operational advantages. Seasons on Mars create a dynamic environment. The presence of water ice is crucial for sustaining life and creating fuel. Mars allows us to live off the land. It's our best candidate for a second home. The Moon offers a strategic foothold in space. Its proximity allows for quick return trips and real-time communication. The Moon is a stepping stone, a base for further exploration. Its low gravity makes it an ideal launch pad. Water ice at the poles can provide resources and fuel. A lunar base could revolutionize space exploration. Exoplanets excite us, but they are out of reach. The closest, Proxima Centauri b, is over 4.2 light-years away. Current technology would take thousands of years to reach them. We know little about these distant worlds. Exoplanets fuel imagination, but aren't practical destinations. Our future lies within our solar system. Mars and the Moon are logical choices for exploration. They balance ambition and feasibility. The Moon is our training ground, a place to test technologies. Mars is the ultimate prize, a step toward becoming multi-planetary. Establishing a settlement on Mars would be a historic achievement. The Moon and Mars are parts of a grand strategy. They extend humanity's reach beyond Earth. Mars and the Moon offer hope for humanity's expansion. They are harsh but reachable environments. They have resources like water ice and are within our lifetime's reach. The Moon could be our launch pad. Mars, our first settlement. These worlds won't replace Earth but are our next chapters. By exploring them, we explore our species' future. The journey has begun with every rover and rocket.
Now that we've explored why Mars and the Moon are our top candidates for human settlement, let's face the real question. What's stopping us? It's one thing to plant a flag. It's another to stay. The universe is indifferent to our survival. Living beyond Earth means confronting life-or-death challenges our biology never evolved to handle. We'll break down the biggest obstacles: cosmic radiation, thin air, alien dust, and the immense distance from home. This isn't a story of impossibility. It's a story of problem-solving on a cosmic scale. Let's begin. Take a deep breath. That's Earth's atmosphere. A life-giving blanket of gas we take for granted. On the Moon, there's no atmosphere. Step outside without a suit, and your body would be destroyed by the vacuum. Mars has an atmosphere, but it's 100 times thinner than Earth's, and mostly carbon dioxide, unbreathable and toxic. The first rule of off-world living: bring your own environment. Every habitat, rover, and spacesuit must be a sealed, pressurized bubble of Earth, constantly monitoring and replenishing oxygen, scrubbing CO2, and maintaining temperature. A single leak is catastrophic. These systems must run flawlessly for years, not days. We can't just ship endless oxygen from Earth. Long-term survival means making air from local resources. On Mars, experiments like MOXIE have shown we can turn CO2 into oxygen, a crucial step. This reliance on technology is a profound shift. Every breath is manufactured, every lungful a testament to engineering. On Mars or the Moon, the hum of life support is the soundtrack to survival. Earth's magnetic field and atmosphere shield us from deadly cosmic radiation. The Moon and Mars lack this protection. Astronauts there face relentless bombardment from galactic cosmic rays and solar storms. These high-energy particles can tear through DNA, increase cancer risk, and damage the nervous system. The best defense is mass, building habitats underground or covering them with meters of local soil. Water also shields against radiation, so lining habitat walls with water is a smart dual use. Spacesuits offer little protection. New materials and active magnetic shielding are being explored, but for now, limiting time outside and having storm shelters is essential. Radiation is one of the biggest showstoppers for long-term missions. Our bodies are built for Earth's gravity. On the Moon, gravity is 1/6 of Earth's. On Mars, it's about 1/3. In low gravity, bones weaken, muscles atrophy, and the heart shrinks. Astronauts on the ISS lose up to 2% of bone mass per month and need months of rehab after returning. Settlers will need intense daily exercise to slow this decline. Artificial gravity, spinning habitats, remains a distant, complex solution. For now, exercise, nutrition, and new medical treatments are our best tools to keep bodies strong in low gravity. The ground and air of the Moon and Mars are hostile. The Moon swings from 127 degrees in sunlight to 173 degrees at night, 2 weeknights, at that. Mars is less extreme, but still ranges from 20 degrees to 73 degrees near the equator. Habitats and suits need robust heating and cooling, consuming precious energy. Dust is another enemy. Lunar dust is sharp and abrasive, damaging equipment and irritating lungs. Martian dust is fine, toxic, and ever-present, whipped into planet-wide storms that block sunlight and threaten power supplies. Advanced filtration and dust-proofing are essential for survival. Every venture outside is a battle against freezing, boiling, and abrasive dust. Off-world, resources are scarce and hard to extract. Water is top priority for drinking, growing food, and making oxygen and fuel. On the Moon, water is frozen in shadowed craters. On Mars, it's locked in ice and minerals. Extracting it requires mining, heating, and purification, energy-intensive processes. Once you have water, you can split it for oxygen or pull oxygen from Mars's CO2-rich air. All of this demands abundant, reliable energy. Solar panels are vulnerable to dust and darkness. Nuclear power is likely essential for a self-sufficient outpost. Without energy, resources remain out of reach. The final challenge is distance. The Moon is 3 days away. Mars is 6 to 9 months, with launch windows every 26 months. Communication with Mars has a delay of up to 22 minutes one way. No real-time help from Earth. Martian crews must be self-reliant, engineers, doctors, mechanics, and more. Every supply must be sent in advance. If something breaks, you fix it with what you have. Psychological stress is immense, years in isolation, with only a handful of crewmates and a tiny blue dot in the sky. Crew selection and mental resilience are as critical as any technology. Living on Mars or the Moon is possible, but only if we solve the problems of atmosphere, radiation, gravity, extreme environments, scarce resources, and human resilience. Each challenge is a mountain, but science climbs higher every year. The journey to becoming a multi-planetary species is a marathon of ingenious solutions. The dream of seeing a sunrise over Olympus Mons or Earth from a lunar crater drives us forward. If you're inspired by this journey, subscribe to For Science Salah Lotfy channel, where we bring the future of space exploration to life. Thank you for watching. Welcome back, explorers. Last time, we weighed the pros and cons of settling on Mars, the Moon, or distant worlds. Now, let's ask, how far has science come by 2025? Are we closer to making space settlement a reality? Today, we'll explore the tangible progress and innovations paving the way for humanity's future among the stars. Let's dive in. To prepare for life on Mars, we simulate its conditions on Earth through analog missions. Scientists create isolated habitats in extreme environments like Utah deserts and Antarctica, mimicking Martian conditions. Crews live in these habitats, testing life support systems where everything is recycled. Air is scrubbed of CO2, and water is purified and reused, even from urine. Food is grown using hydroponics and aeroponics, experimenting with crops that thrive with minimal resources. Beyond technology, these missions test psychological resilience. Crews face isolation, studying teamwork and stress management to ensure future astronauts are mentally prepared for space. Astronaut training in 2025 focuses on mental and emotional challenges of long missions. With trips to Mars taking months, astronauts face isolation like never before. Agencies incorporate psychological resilience training, simulating stress and communication delays. Astronauts learn to make critical decisions autonomously. Interpersonal skills are crucial. Astronauts train in extreme environments, learning to resolve conflicts and support each other, functioning as a family. The goal is to prepare astronauts to thrive in deep space, carrying humanity's hopes on their shoulders. By 2025, interplanetary travel technology is advancing rapidly. Reusable rockets, pioneered by companies like SpaceX, have revolutionized spaceflight economics. New heavy-lift vehicles can send massive payloads to other planets, enabling pre-deployment of habitats and supplies. Cargo landers autonomously land with precision, setting up base camps before human arrival, increasing safety. Interplanetary transfer vehicles are designed as long-duration habitats with life support and radiation shielding. The vision is a sustainable transportation system between Earth and other celestial bodies, with concepts like orbital refueling depots becoming reality. Scientists in 2025 explore adapting life for space. Engineered microbes could make Martian soil fertile and produce oxygen from CO2. Gene editing tools create space crops resistant to radiation and efficient under LED lights, providing reliable food sources. Research also focuses on protecting human bodies from microgravity and radiation. Studying animals like hibernating bears could inspire solutions. Theoretical human adaptation explores genetic tweaks for multiplanetary living, raising ethical questions but showing a shift from visiting space to living there. By 2025, are we close to settling space? Yes and no. We're closer than ever, with progress changing the conversation from if to how and when. Major investments are in real hardware, with a clear plan: return to the Moon, then Mars. Challenges remain, like perfecting life support and solving radiation exposure. Testing in actual environments is crucial. The journey is long, but momentum is building. We're transitioning from a dream to an engineering project, taking our first steps on a visible path to becoming a multiplanetary species. We've explored the edge of possibility, from Martian gardens to revolutionary rockets. The path to a spacefaring civilization is being paved now. Challenges are huge, but global ingenuity is greater. We're living in a pivotal moment, with thrilling years ahead. Support our journey by subscribing to For Science Salah Lotfy channel. Your support helps us create deeper content and explore the future. Thank you for being part of this community. Keep looking up, stay curious. All right, explorers, now that we understand the challenges, let's jump into the part everyone loves. What could our future in space actually look like? Today, we'll explore 3 realistic scenarios. One near, one mid-range, and one far, far ahead. Let's imagine them together. Picture this, a small sealed habitat sitting quietly on the lunar surface, or perched on the dusty plains of Mars. This isn't a city. It's not even a village. It's more like an advanced research station, similar to Antarctica's bases, but much more isolated, and much more extreme. Here's what it would look like. Scientists and astronauts living inside a dome, a capsule, or a protected laboratory. Stays lasting weeks or a few months, not years. All air, water, food, and energy carefully controlled. Limited outdoor activity, and only with full spacesuits. Most of the work focused on geology, resource extraction tests, growing plants, and understanding how humans handle the environment. This scenario is the most achievable one. In fact, we're already testing many of the technologies needed for it. But even so, it's challenging. Radiation shielding must be strong, life support must be reliable, and psychological support must be excellent. Still, a temporary research outpost is the closest and most realistic first step. Now let's push the imagination further. This time we're talking about a tiny human settlement, the first actual colony, but very small. Maybe 20, 30, or 50 people max. This future becomes possible only if key technologies reach maturity. Robust life support systems that run for years. Solar or nuclear power sources that can handle constant demand. Greenhouses for food. Local resource use, especially extracting water ice for fuel, drinking water and oxygen. Radiation-protected homes, maybe underground or built with local materials. In this world, settlers can live longer than just a few months. But it's still hard. They depend heavily on supplies from Earth. Repairs are difficult, medical emergencies are dangerous, and every small problem, even a broken valve, could be life-threatening. This is a scenario humanity could reach in the coming decades if technology advances steadily. It's inspiring, but it requires tremendous discipline, engineering power, and global cooperation. Now, let's leap far into the future. Imagine fully developed settlements, or even entire cities, that can survive without constant support from Earth. Homes protected from radiation, artificial environments with stable temperatures, breathable air, and long-term agriculture. Biological advances allowing crops, or maybe even humans, to adapt better to low gravity or limited sunlight. Energy systems capable of running for decades. And maybe children growing up in these places, forming the first generation of off-Earth humans. It's a powerful vision. If you're enjoying this journey into the future, make sure to subscribe to For Science Salah Lotfy channel. Your support helps keep these deep, science-based explorations alive. So, after everything we explored today, let's return to the big question that started this journey. Can humans really live on another planet? The honest answer, at least for now, is maybe, in very controlled artificial conditions. Not naturally, not comfortably, and definitely not the way we live here on Earth. If humanity goes to Mars or the Moon, it will be inside protected bases, sealed habitats, and fully engineered environments. Not open landscapes or free breathing under alien skies. But that raises an even deeper question. Why do we want this so much? Is it because we hope for a backup home? A plan B if Earth becomes unlivable? Is it pure scientific curiosity? The desire to push boundaries, explore, and understand our cosmic neighborhood? Or is it simply part of our nature as humans? To look up, to dream, and to wonder what lies beyond? Whatever the reason, one thing stays absolutely true. Before we run to another world, we must take care of the world we already have. Earth is still the only planet where humans can walk outside, breathe freely, grow food under natural light, and live without layers of technology protecting their bodies. It is our safest home, and it deserves our attention and protection. But now it's your turn. If someone offered you the chance to live on Mars, inside a habitat with limited space, limited resources, and no way to step outside without a suit, would you go? And, why or why not? Tell us your answer in the comments. Your ideas, your imagination, and your perspective could shape the next part of our exploration. Because yes, This episode could be the beginning of a whole new series. We can dive into life on planets outside our solar system, or explore the future of life support technologies, or even discuss the ethical questions of creating human settlements in space. If you want us to continue this journey, let us know. And before you go, don't forget to subscribe to For Science Salah Lotfy channel. Your support helps us bring more research, more science, and more curiosity directly to you.